Good morning, students. In this lecture, we will learn some basic concepts of symbolic logic. To fully understand deductive reasoning, we need a theory of deduction to explain the relations between premises and conclusions, and also to provide techniques for discriminating between valid and invalid arguments. Earlier on in the semester, we learned several techniques. We talked about Aristotelian logic, classical logic, the square of opposition, categorical syllogisms, and we tested categorical syllogisms using the three Venn diagram technique. Now we consider modern logic. This is what modern logicians work on nowadays. And one aspect of modern logic is called symbolic logic. So traditional and modern approaches to logic have the same aim. But they obviously they vary in the way that they approach logic. Modern logic uses what is known as an artificial symbolic language. That's why symbolic logic is called symbolic logic. Why this? Because think about, for example, any language, the English language, for example. We use terms that sometimes are vague. They have double meaning, we use metaphors, and so on. So traditional logic is not able to capture those nuances of language, like metaphors and double meanings and so on. Consequently, a symbolic language comes very useful to in assessing arguments. To give you an analogy, think about how difficult it would be to multiply numbers using classical Roman numbers, Roman numerals. It would be quite difficult to do. On the other hand, by using numbers that we use normally, you can see it's very easy. It makes it easier. Symbolic logic so uses symbols, okay? And so in this lecture, I will teach you the symbols used in logic, and we learn their functions and what they are and what they do. Now let's start with this notion that probably this semester alone I must have said a trillion times, that arguments may contain compound statements. Statements are either simple or compound. Okay? A simple statement is a statement that contains only one statement. For example, Charlie is tall. This is a simple subject-predicate statement. Also, there are arguments that contain compound statements. For example, a statement that has one or more statements attached to it. For example, Charlie is tall and Charlie is intelligent. This is an example of a compound statement. Okay, so we have two statements. In other words, it's like saying we have two statements in one. We have Charlie is tall and Charlie is intelligent. This particular statement, this one, Charlie is tall and Charlie is intelligent, is conjoined by the word and. Okay? But there are many other ways that we can put together two statements to form a compound statement. So for each way that we put together two statements, we have a different symbol. So let's talk about symbols in logic. Now, before I showed you the next slide, let me just make a simple point. The following symbols are the symbols used in your textbook. Different textbooks vary in the way that they use symbols. Well, there are a couple of ways that logicians use symbols. This way of using symbols is my way. I mean, not my way, my personal way, but it's the way I prefer to use symbols, okay? There are other ways using arrows. I think all the other ways, if you, for example, go on Wikipedia or you Google symbols, logical symbols, you'll find different things, different shapes, different forms, arrows, and so on. I don't like those symbols. I think these symbols, the following symbols, are very clear. I think they're very functional. So you're going to learn these. And in any case, you have a textbook, so you have to refer to your textbook. Let's start with the first symbol. The first symbol is what we call conjunction. We talked about it before, just a minute ago, in the example just given, when two simple statements are conjoined together with the word and. Okay, so Charlie is tall and Charlie is intelligent is a conjunction. The conjunction, again, is we use the word and. Each part of the conjunction, each sentence, simple sentence, is called a conjunct. Okay, so there are two conjuncts in this particular statement. The symbol that we use to connect statements like Charlie is tall and Charlie is intelligent is the plus sign. Okay, as I said, other textbooks, other logicians have their different signs. It seems to me, and you'll be the judge, the most logical, since we are studying logic, the most logical way of conjoining two statements is to use the plus, because it's one plus the other. Okay, so we may symbolize the statement as follows: Charlie is tall plus Charlie is intelligent. As we will see in a couple of minutes, we can further symbolize the each statement. So, for example, Charlie is tall. We can use a letter, for example, a capital T, to symbolize Charlie is tall, or a C. That's arbitrary. Now, I know what you're thinking, but what's going to happen in a test? What are you going to do? Well, in a test, if I ask you a question to symbolize statements, I will provide the letters that I want you to use. Okay, so and also Charlie is intelligent. We may symbolize that with an uppercase I. Okay. So the point of symbolic logic, what we are trying to work toward now, is to be able to symbolize everything. Okay. The reason is because categorical logic, as we learned in a previous lecture, is not flexible enough. What I mean is that in order to deal with categorical logic, you need a categorical statements. The arguments, syllogisms are expressed in categorical statements. But what if you have an argument that is not expressed in categorical form? This is why symbolic logic is very helpful. So, the compound statement above may be a premise to an argument. For example, Charlie is tall and Charlie is intelligent. Therefore, Charlie is intelligent. Okay? Or any other argument. Charlie is tall and Charlie is intelligent. If Charlie is tall and Charlie is intelligent, then Charlie will study. Therefore, Charlie will study. Any argument of that kind, as you can see, cannot be captured by symbolic by syllogistic logic. Okay. So the argument can be stated completely by using symbols, as you can see. So we have to decide which letter are we going to use for which statement. So I chose T, as I said before, for Charlie is tall. The plus sign is the conjunction, the and the capital I is for Charlie is intelligent. So when, as I said, the point of symbolic logic is to be able to symbolize arguments, and we can symbolize that argument, as you can see here on the bottom of the screen. We have T and I. Okay, the plus sign, we always read it as and the three dots. These three dots are not a mistake or I didn't know what to do this morning. The three dots in logic signify therefore, signify that there's a conclusion. Therefore, I. Okay. Let's talk about truth value. We talked about truth value before. Since every statement is either true or false, we say that every statement has a truth value. Now, each statement has a truth value. Okay? So Charlie is tall can be either true or false. Charlie is intelligent can be either true or false. But also, the entire compound statement has a truth value. In other words, let's put it in quotation marks. Charlie is tall and Charlie is intelligent. This statement, this compound statement, can be either true or false. Now, the truth value of a compound statement depends on the truth value of its individual components, individual statements. In this case, each conjunct of the statement, Charlie is tall and Charlie is intelligent, will have a truth value, and each value will affect the truth value of the entire compound statement. Let me explain what I mean. Now, first of all, let me say this. A conjunction is said to be a truth functional compound statement. And its conjuncts are truth functional compounds. But labels and names and terminology is not so important at this point, at least not this one. Okay? And the symbol itself, the plus sign that we call conjunction, and we read and, is a truth functional connective. Okay, these are important, but what's important is to understand the process and the concept, not so much remember the terms. So let me explain how this is going to work. Given these two statements, there are four possible ways, possibilities, and four possible sets of truth values. Okay. Now, when Charlie is tall is true, and Charlie is intelligent is true, the compound statement is going to be true. When Charlie is tall is false, and Charlie is true, Charlie's intelligent is true, the entire compound statement is false. So as you can see, the only way, the only arrangement that makes the entire compound statement true is only when the both conjuncts are true. Let me represent that with this truth table. Okay, as you can see in this table, T is Charlie is tall, I is Charlie is intelligent, and T plus Y is Charlie is tall and Charlie is intelligent, the entire compound statement. Right. So, as you can see, when T is true and I is true, the compound statement is true. When T is false and I is true, the compound statement is false. True and false make it false, and false make it false. But this should be easy to understand. Okay, if you want the statement Charlie is tall and Charlie is intelligent to be true, each individual component of that compound statement must be true. This is really easy to understand. Let's talk about the next connective, logical connective. The next one is the negation. Now, obviously, any statement can be negated. You can say, Charlie is tall, and I negate that statement. So I say, it is not the case, or it is false, that Charlie is tall. The symbol that we use is the minus sign. Simple as a minus sign. And we place the minus sign in front of a statement that we wish to negate. So if we want to negate the statement, Charlie is tall, we say minus T, okay? And we read it, it is false that Charlie is tall, or it is not the case that Charlie is tall. This is very simple. Instead of Charlie, let's change example. Let's use P for popcorn is good, and not P for popcorn is not good. Okay, so as you can see, if popcorn is good is true, the negation of popcorn is good will be false. And if popcorn is good is false, then the negation obviously would be true, because that's what the negation states. So this is very simple. Okay, now let's talk about the disjunction. Disjunction is read as or. A disjunction is, it's very normal to use disjunctions. We do it all the time. We say, either you come to my party, or you're not a cool dude, or either you're wearing glasses or you're wearing contact lenses. We do this all the time. We use disjunctions all the time. The symbol that we use for the disjunction is a lowercase v, a letter V. I believe some other logicians use the same symbol, but upside down. Now, each statement here is it's called a disjunct. So, notice what happens here. Let's go back to our example of Charlie is tall and Charlie is intelligent. If Charlie is tall is true and Charlie is intelligent is also true, the compound statement in this case is Charlie is tall or Charlie is intelligent. So naturally you can see that if I say to you, it is true that either Charlie is tall or he is intelligent. So whichever one you pick, okay, whichever one you pick, if one of these two options is true, the compound statement is going to be true. Now in this case, both options, as you can see, are true. Consequently, the truth value of T or I is T, is true. And similarly, when one of the options is false and the other is true, we still have a truth value for the compound statement. Again, if I say either you wear contact lenses or you wear glasses, and you say to me, it is false that I wear contact lenses. Okay, so the compound statement is true because to be true, you have to satisfy one of the two options, or in other words, one of the two options must be true. Notice, however, that the only way that the compound statement is false is, of course, when both options are false. So if I say either Charlie is tall or Charlie is intelligent, but if you say, well, it is false that Charlie is tall and it is false that Charlie is intelligent. Now, consequently, this would make the compound statement Charlie is tall or Charlie is intelligent false. All right, let's consider the next connective. The next one is what is known as a conditional statement. A conditional statement, typically in the English language, is formed by the words if, then. Okay? For example, if you are thirsty, then you should drink a glass of water. Now notice that the then is not necessary. Very often in the English language we say, if you are you're hungry, eat. Or if you have nothing to do tonight, come over to my house. Okay, we don't use the then. But the then is always implied. Now, take an example. If I graduate, then I will get a job. Once again, we don't need to use the then, but it's implied. If I graduate, I will get a job. Notice that there are two statements, okay? So the first statement, the one before the comma, if I graduate, is known as the antecedent. And the second is known as the consequent. Okay, let me see what I wrote here. The first statement is antecedent. The second is the consequent. Sorry, this is a mistake. This should say the second is the consequent. I have to correct this little mistake. Okay. So which symbol do we use for this? For the if-then, for the conditional statement, we use what is known as the horseshoe, or the lazy U. Okay, lazy U. Now, this symbol is, as you will see, is placed between two statements. So, if I graduate, then I will get a job. Let's call, if I graduate, let's use a G to represent it. And for I will get a job, we use a letter J. Okay? So if I were to symbolize this compound statement, I would do capital G, then my lazy U in between, okay? Capital G, lazy U in between, and then capital J. So it would be, I graduate, if then I will get a job. Now, any conditional statement, we have to talk about this for a moment. Any conditional statement is false only in the event that the antecedent is true and the consequent is false. Think about it. Let's go back to this slide. Let's consider this example. If I graduate, then I will get a job. So suppose that you graduate, and this is true. Okay? So you graduate is true. Now, what happens if you graduate? You have to get a job. Now, if you don't get a job, so if the consequent is false, now naturally the whole compound statement becomes false, because to be true, the antecedent must be true and the consequent must also be true. In other words, a conditional statement says the truth of the antecedent is predicated upon the truth of the antecedent. I'm sorry, the truth of the consequent is predicated upon the truth of the antecedent. Okay? So if the antecedent is true, the consequent must be true. Otherwise, the compound statement is false. Okay? In any other combination, true and true, false and true, false and false, makes the statement, the compound statement, true. Okay? All right. The next one is what is known as the material equivalence. This is a symbol that we read as if and only if. The symbol that we use is 3 bars, if and only if. Sometimes in books or in arguments and papers, you see it symbolized as IFF, which means if and only if. Now, for the material equivalence, to be true, the compound statement, you have to have the same truth values for the statements. So every time the statements have the same truth value, the truth value for the compound statement is true. The only way that the compound statement is false is when, as you can see, when the truth values of the individual statement are different. Okay? So Charlie is tall if and only if Charlie is intelligent. See, they depend one on the other. Okay, so take a deep breath because we are discussing a new topic. The next topic is punctuation. Now think about this. I just taught you how to translate arguments into symbols, logical symbols, using connectives and the purpose of that is to manage arguments and to translate the arguments into symbols. It's much easier to have symbols because for our purpose later, when we construct truth tables and we test arguments for validity, it's going to be easier for us to have an argument that is completely symbolized. So since arguments have punctuation, for example, an argument could be, if I graduate, then my father will buy me a car. I graduated, therefore my father will buy me a car. You can have more complex, more complicated statements. And in order to understand statements, we have to understand punctuation, how we group statements and we make sense of statements. So just like in normal language or in mathematics, let me give you these two examples. Look at these two sentences. The first one says, the teacher said John is intelligent. The second sentence, I added punctuation. As you can see, I have two commas. The teacher said John is intelligent. Now, you can see that without punctuation, these two sentences have different meanings. The teacher said John is intelligent. And the teacher said John is intelligent. Now, in the first sentence, who is intelligent? Is John intelligent or the teacher intelligent? In the second example, we can see that John said that the teacher is intelligent. So it has a different meaning. Similarly, in mathematics, when we say 2 times 3 plus 5, and we say 2 times parentheses 3 plus 5, we mean two different things and two different results. So symbolic logic is the same. We use parentheses, we use brackets, we use braces to create different meanings in order to preserve the meaning of a statement. Now, let me give you an example. Let's consider this statement. It is not true that if Max runs, then Bill swims and John fences. Now, what I mean here is the following, that if Max runs, then Bill swims and John fences is false. Okay? Let me read it again. It is not true that. What is not true? Everything is not true. Namely, that Max runs, then Bill swims, and John fences. You see? So in order to preserve this meaning, in order to preserve the meaning that I mean that the entire sentence is negated, is false, is not the case. The entire conditional statement is false. I need to separate different statements using punctuation. Okay? Notice that further that within this compound statement, within this complex statement, we have a conjunction. The conjunction is Bill swims and John fences. So the question is, since we have a conditional statement and a conjunction on the other hand, how do we make sense of the conjunction and the conditional statement? Are we referring to the first part of the conjunction or the first or the second part? So it may get confusing if we don't use proper punctuation. So to illustrate what I mean, first we need to translate the statement. Now let's have the statement. This is the technique that I use, okay? And you can use any other technique, whatever feels comfortable to you. When I was in school, I remember when I was in school and I learned logic. When I was in college, and my professor made me translate statements. Well, I developed my own technique. It's not a rocket science, okay? It's not the greatest invention of the 20th century, because that's when I went to school, the 20th century. But anyway, it's my technique. You can develop your own technique, whatever works for you. But here's the story. In the exam, I will give you a statement just like this, and I'm going to ask you, symbolize the statement and make sure that you use correct, proper punctuation. Okay? So, what do? You take your statement, and the way I do it is that I underline full statements. Okay? So as you can see, I do not underline "it is not true that," because this is going to be, this sentence here, this phrase here, is going to be translated into a minus sign, a negation. Also, I don't underline the if, because if is not a complete statement. I mean, it's not a statement. So I underline Max runs. I don't underline then, but I underline Bill swims and John fences. Okay? So first you underline your statements. Now you know that all the statements are underlined. Secondly, you circle. Again, this is the way I do it. Maybe you can put a dot on it. But I like to circle it. I circle all the connectives like such. Okay? The second step. So the first step is underline and circle. Second step is assign letters to symbolize only statements, only full statements. So Max runs, we call it M. Bill swims, we call it B. And John fences, we symbolize it with an F. Now, next step. Third step. We rewrite the sentence using symbols. Okay? So, it is not true that is going to be symbolized with a minus sign. Maybe it's too tiny. Maybe I'm going to make it a little bigger. But you can see it. The if Now, think about this. I don't translate if and then separately, because if then are one symbol. Remember the lazy U. So first I put Max runs, and then in between Max runs and Bill swims, I use the lazy U, the conditional sign, the if-then sign. Because remember that the if-then sign, so the conditional statement is if Max runs, then Bill swims. So I do M, if then, and then B. Okay, the next symbol is going to be the and, which we translate with a plus sign. And finally, the last statement, which is F for John Fences. Now, as you can see, we have minus M, or not M, if then B, and F. But now think about it. How do we read this statement? Do we read it B plus F, or M if then B? And what about the minus sign? Do we wish to negate M, or negate only the if then, or negate only B plus F, or negate the whole thing? Without any parentheses, I don't know what I'm negating. Consequently, I need parentheses. I need parentheses to say, this is what I'm negating. I'm negating all this. Okay? Now, this is the statement, again, as I read it before, minus negative M, or not M, if then B plus F. Okay? As you can see, as I said, it's ambiguous. We don't know what these signs are supposed to apply to. All right, so the fourth step is to use parentheses, brackets, and other things if needed. And as you can see, we symbolize it this way. I have brackets and parentheses. Now look, for example, B plus F. B plus F go together. Now it is true that B is part of a hypothetical. Okay, it's part of this statement. It's a conditional statement. But remember that a conditional statement has an antecedent and a consequent. So the question is, which is the antecedent? Well, we know the antecedent is Max runs, or M. But which is the consequent? Is the consequent only Bill swims? No, the consequent is Bill swims and John fences. But Bill swims and John fences is also a conjunction. So what do? Well, we put the conjunction in parentheses because we have Bill swims and John fences. They go together. You cannot separate them. But at the same time, I want to separate him because the conjunction B plus F is the consequent of a conditional statement whose antecedent is M. So we have M, if then, B plus F. Now notice that in addition to parentheses, I also have brackets. Why do I have brackets? Because if I don't put brackets, then all I do is I negate M. but I don't want to negate M only. I want to negate the whole thing. So I put brackets and a minus sign outside the brackets, symbolizing that I'm negating the entire thing. Easy? No? Let me give you another example. Let's make the same statement a little more complicated. It is not true that, what? That if Max runs and Bill swims, then John fences. And it is not true that Max runs or Bill swims. Once again, let's underline all the statements. Then circle all the connectives. Then we decide a letter for each statement. Max runs as M, Bill swims, same as before, M, B, and F. The next step, we do a step by step. We just substitute the statements and we translate it into letters. Another step, we translate everything. Now, as you can see, I have no parentheses, and again, in this case, am I negating M only? No, I'm negating more than M, but I'm not negating everything. Not everything, as you can see. So, what's the next thing that I have to do? Well, the next thing that I have to do is to isolate M and B, because M and B are in this case, in this example, we have the conditional statement where the antecedent is M and B, and the consequent is F. So I have to put in parentheses M plus B, and also I need to put in parentheses M or B, okay, because they go together. Now, I'm negating M plus B, and this is a hypothetical conditional statement. So you see, this is the antecedent, M plus B is the antecedent, F is the consequent. But wait a minute. Now we have F plus the negation of M or B. So which goes together? Well, if you read the original sentence, you should know what goes together. So to make to save the sense, the original sense of the statement, we need brackets. But this time the brackets are around the conditional statement, which I negate. So I negate the conditional statement. It is not the case that if M plus B, then F. And I have a second statement, which I negate. And the second statement is a disjunction, M or B. Easy? Let me give you one last example. Then you should go use your textbook. I listed page numbers on my syllabus. There are exercises on your textbook. Do a couple of exercises, practice. If you have questions, you may contact me. Once again, this is a different statement. If the president vetoes the bill, or if Congress balks and the people protest, then the chances of passing the year's new tax amendment are not good. Notice I underlined all the statements. This is a very long statement, but remember this. I don't care how long the statement is. It can be as long as from here to Timbuktu. The point is, for each individual statement, you use a letter. So this one is going to have a letter, its own letter. Next thing, we circle all the connectives. Next step, we decide the letters that we use. So we use V, C, and P, and G. Now, let's put it together. Whoops. If V or if C and P, then not G. Or in other words, if the president vetoes the bill, that will be the V. Or if C and P, then G. Not G, actually. Okay, so C and P should be grouped together because, remember, it's a conjunction, C and P. So we know we use parentheses and we put them together, we isolate them. Furthermore, the whole statement is a conditional statement. Remember, if, then. So the antecedent is all this, V or if C and P, and the consequent is G. So what do? We put it this way. If V or if C and P, then not G. Now I need to do one more thing. I need to bracket. I need to bracket the antecedent, because the antecedent is not only V, but is C plus P. But C plus P is already in parentheses, so what I do, the next thing I use brackets. And now, as you can see, I completely symbolized it. We have in brackets the antecedent, and outside we have the consequent, which is the negation of G. I hope this was helpful. As I said, you have to practice, because I realize that the explanation might be not very clear. It's confusing. The first time you do this is confusing. It was confusing to me too, okay? Even though I teach logic, it was confusing at one point. When I first heard logic and symbols, I was confused. The reason why I mastered this is because I practiced and practiced and practiced and practiced, okay? I know you are students, you don't want to be logicians, you have other things to do, but what can I tell you? You signed up for my course, and this is what you get. Now, but practice. There are many exercises in your textbook, so practice. Okay, one more example. It is not true that if and then. We have an if and a then, okay? So we know that we're dealing with a conditional statement. So if we are dealing with a conditional statement, we have to understand which is the antecedent, which is the consequent. But again, let's do it step by step. Let's underline all the statements and let's circle all the connectives. Next step, we decide that we use I for I am innocent, A for I have an alibi, and I go to jail for J. I mean, J for I go to jail. Next step, we may, in the next step, you see, this is helpful if this is confusing. If this is confusing, the first time that when you practice or on an exam, I would do it step by step. Now, at this point in my life, I don't need to do it. I don't need to do it step by step. I can translate it in my mind and write it out completely. But I realize that it might be confusing for some. So what I suggest is that you translate step by step. In other words, rewrite the statements in the form of symbols, and don't just yet translate everything. So do it step by step, or whichever way works for you. That's the way I do it. So it is not true that if I plus not A, then J. In the next step, you group together whatever goes together. The conjunction goes together. So I and not A go together. Again, parentheses. Now, in the following step, we have to negate the entire thing. Remember, because the sentence starts with, it is not true that, so you want to negate everything. And since the antecedent is the negation of I and not A, then the consequent is going to be only J. And that's the way we completely symbolize it. Now, why is this important? This is very important because in the next lecture, I will teach you how to symbolize not only one sentence, but an entire argument, premises and conclusion, and construct a truth table and test the argument for validity. This is a very useful thing. So first you have to master this. First you have to understand and learn how to symbolize arguments. Then we can look at constructing truth tables. Now, the final step, since I am negating everything, I'm negating the antecedent, but I'm also negating the consequent. The only way to do that is to bracket the conditional statement, and now I negate everything. Now, this is the end for now. As I said, in the next lecture, we are going to learn how to put this together and to construct truth tables. Thank you very much. I'll see you in the next lecture.